So far, we've looked at selectivity in the context of just a single column. But as we all know, we frequently have indexes that contain multiple columns, so let's turn our attention to these composite indexes. The denominator, the number of rows, is easy. That's just the same query as before. For a multi-column index, though, we need to know the number of unique combinations between all of the columns that are involved in the index. This will equate to the number of unique keys in the index. Now what you can't do is use a countDistinct function over multiple columns. Oracle will return you an error because that's not supported. But what you can do is something like this. Reading from the inside out, first we're going to determine all of our unique combinations that exist for these columns with our Select_Distinct query. And then this whole query is wrapped in an inline view so that we can count the number of distinct values. So this really isn't much different than what we did earlier. The syntax just looks a little bit different. How does this apply when we have an index that has multiple columns, but our SQL statement is using only a subset of those columns? To answer this, let's go back to an example that we looked at earlier in the module, where we have this composite index over 3 columns, last name, first name, and state, and that is the order of the columns in the index. So we could run the queries from the last slide, and we would calculate the selectivity of the index based on those 3 columns. However, this selectivity is only going to apply if we have all 3 columns specified in our SQL statement. So what happens when we have a statement like this, where our SQL statement has conditions for the first 2 columns in the index? The answer is that the selectivity for the index for its use in this statement is calculated over the first 2 columns in the index, because these are the only 2 columns that this statement is using. So Oracle can still use the index, it just won't be quite as selective as if all 3 columns were used. Now let's consider another SQL statement that we looked at earlier. And in this statement, we again have 2 columns of our index present as conditions in our where clause. But in this case, it is the first and third columns that are present. As we talked about earlier, column order matters. And what our selectivity is based on is the number of consecutive columns from the beginning of the index that are present in the SQL statement. So in this case, that is just one column, the last name column. So it is the selectivity of this column that matters when determining if it is efficient for Oracle to use this index. The point of all of this, though, is that Oracle can use an index when only some of the columns in the index are specified in the SQL statement. But in these cases, the selectivity of the index is determined not by all of the columns in the index, but on the leading portion of the index that contains columns that match columns specified in your SQL statement. And so if this subset of columns is not selective enough, Oracle may choose to use a different index or resort to a full table scan.